Hello everyone, welcome back to Let's Solve. In today's video, we are going to solve another previous year question from 2011. And today's video is regarding atmospheric layers. Specifically, it's regarding the ionosphere. Now, before going into the explanation, please pause the video and see if we can solve this question. First of all, let's start with the layers of the atmosphere. The troposphere, stratosphere, mesosphere, thermosphere, and the outermost layer, which is exosphere. These are the atmospheric layers. And among these layers, the weather events, climatic phenomena, everything takes place in troposphere, right? The upper part of the troposphere is through which the jet aeroplanes and everything they are flying through. And in stratosphere, we will be able to find like the ozone layer, which protects us from the UV radiation. And regarding the mesosphere, it's the coldest region in the atmosphere. Like the temperature can be as low as say minus 80 degrees Celsius. In thermosphere, due to the direct impact of sunlight, the temperature will be very high. Now, today's video is regarding a region within the thermosphere, right? So here in this picture, you can see that like the aircraft and all flying through the troposphere or the upper troposphere, ozone layer in stratosphere, and like the weather balloons will be extending all the way up to the top of the stratosphere. They won't be able to reach the mesosphere. So today's video is regarding ionosphere, which is the region within the thermosphere. Okay, as the name suggests, this region, ionosphere, is having more ions in it. Ions means they are charged particles, like the atoms having positive or negative charge. Like suppose consider oxygen, right? Oxygen we write it as O2. It's not having any charge. But if it's staying as separate atom, right? It will be having separate charges. So these charged particles are seen in this, or the concentration of the charged particles are high in ionosphere. Importance of the ionosphere is that it facilitates radio communication, right? Think about like in an age before the smartphones, right? Like if you're communicating to radio, what happens is that we need to transmit the radio waves. If you're emitting say radio signals from one of the weather stations or like one of the signal towers, it needs to be transmitted to the other part of the earth. So the signals needs to go up and it has to be reflected back, then only it will be able to reach other parts. Now if you look at today's smartphones, like the signal towers, right? They will be sending these signals to the satellites, and via satellites they will be reaching the other towers, and from that we'll be able to communicate it to the mobile phones. So anyway, if you need to communicate, the signals has to go up and they has to come down. Now before the inventing of before the invention of these satellites and all, we used to communicate through radio using ionosphere, because ionosphere will be having more ions in it, and these ions are able to reflect back the radio waves that are emitted from the surface, so that the radio waves will be received by other the sensors and all, right, other devices. So the most importance of ionosphere, due to the concentration of ions, they will be facilitating radio communication. Another importance of ionosphere is that it is resulting in an optical phenomena which is called as aurora. During aurora, the sky will appear as like greenish or like a bluish in color, and this phenomenon is taking place in the high latitudes of northern hemisphere as well as southern hemisphere. Like in from nations like Norway, you will be able to see sky as lit with different colors. I'm not talking about sunrise or sunset, like the orangish and reddish color we see during sunrise or sunset. Rather than that, the sky will be appearing as as you can see in this picture, right? Like red, like greenish or sometimes blue or sometimes violet. And this is because of the interaction of the charged particles coming from sun with that of the ionosphere. Ionosphere is having charged particles. Same way, the sun's energy, right? Sometimes there will be bursts of energy, and these energy particles will be coming to the Earth's atmosphere as charged particles. So charged particles are there in ionosphere, as well as these charged particles are there in they are coming from the sun also, right? So due to various effects of our magnetic field, these charged particles will be reaching more towards our northern hemisphere as well as southern hemisphere. Like as I said earlier, like the higher latitudes of the northern hemisphere as well as southern hemisphere. So the charged particles coming from the sun will interact with the charged particles in the ionosphere, and this will create the aurora formations, right? The aurora in the northern hemisphere is called as aurora borealis, and in the southern hemisphere it's called as Aurora australis. And another name for this aurora is northern lights and southern light. Now let's see another picture of aurora, and we'll be able to see sky like this from from the high latitudes of northern hemisphere as well as southern hemisphere. So regarding ionosphere, it facilitates radio communication because of they are having high concentration of ions in it, and these ions are able to reflect back the radio waves, and the ionosphere is resulting in the optical phenomena called as aurora. Okay, so it's easy to remember, the aurora borealis is in northern hemisphere, aurora australis in the southern hemisphere. You can relate it with the Australia in southern hemisphere. Okay, now let's solve the previous question. A layer in the Earth's atmosphere called ionosphere facilitates radio communication. Why? And this is a two-statement question. So first of all, we have to understand the question properly. The question is regarding why ionosphere facilitates radio communication. Now, going to the first statement, the presence of the ozone causes the reflection of radio waves to Earth. This is an illogical statement. The ozone layers filters out the UV radiation from sunlight or from the incoming solar radiation. They doesn't reflect back the radio waves or anything. So you can eliminate the first statement. And the second one, the radio waves have a very long wavelength. Okay. Now the question is regarding why ionosphere facilitates radio communication. It's not regarding whether radio waves have a very long wavelength or not, right? The ionosphere facilitates the radio communication because it's having larger concentration of ions in it. So if we didn't understand the question properly, there's a chance that we'll think the second statement is correct, right? So whether this second statement is correct or not, that's not what is being asked here. For this reason, the answer here comes out as D, which is neither one nor two. Actually, the radio waves are having very high wavelength, but that's not the reason why ionosphere facilitates radio communication. Rather than it's because of the concentration of ions. So here answer comes out as D, which is neither one nor two.